Safiah binti Akil, metric number 147768. I'm presenting about Van Allen belt. I hope you will enjoy watching this video. Let's go. So, there are people that questions the legitimacy of astronauts across the Van Allen belt to go to the moon. However, if they could not make it through Van Allen belt, then how did they get to the moon as claimed before? And what is the Van Allen belt? And how is it dangerous for us? Hi everyone! Thanks to our Earth magnetosphere for protecting us from solar radiation from solar storms that carry more plasma and the deadly cosmic rays streaming from the other stars. Without our Earth magnetic field, we will be exposed to the deadly radiation and our technologies are potentially disrupted. All those high-energy electrons that coming from the solar radiation and the cosmic rays were trapped by our protective magnetic field, forming a swirling donut-shaped field of a very harmful radiation called Van Allen belt. A population of those high-energy electrons inhabits the Van Allen belt, and in order to go to the space, the astronauts and the spacecraft must pass through them first. Firstly, let me introduce to you a little bit about Van Allen belt. Van Allen belt was discovered by space scientist James Van Allen and his team in early 1950. Explorer 1 satellite has been launched in February of 1958, led to high radiation environment discovery, and the energetic electrons in the Van Allen belt are called killer electrons due to their strong radiation that can potentially cause satellite anomalies in space through deep dielectric charging. Now we know that the Van Allen belt are potentially dangerous to humans and the spacecraft, but how dangerous they are that the crew of the Apollo missions were able to complete the missions. Since the Van Allen belt is surrounding the Earth, so there's no way to go to the space without passing through them first. Before this, James Van Allen has suggested to detonate a 1.4 megaton bomb to expand the Van Allen belt and clear out the radiation around the Earth. So in 1962, a nuclear test was carried out by launching the Starfish Prime event on July 10 to test whether the attempt was succeed or not. But turns out the explosion ended up adding more radiation around the Earth. Due to that failure, NASA had to create a barrier within the spacecraft and figure out a trajectory that avoided the most radioactive part of the belt while traveling as fast as possible. And this includes using a lighter metal such as aluminium and stainless steel as a shield, because these metals creates less X-ray that resulted from the interaction between the beta particles and the shield. Apart from that, Van Allen belt, we know that Van Allen belt is filled with high energy protons and electrons. And protons can be stopped by the epoxy resin held shields and aluminium skin of craft, while electrons that are known as beta particles, they can penetrate into living tissues. And to stop the penetration of the electron, we can use a material like polyethylene, because polyethylene contains a lot of hydrogen atoms that are lighter and can absorb the beta particles. So both of these materials are used as stopping radiation materials in the astronaut hull. So next, apart from that, the scientists also determined the speed of the Apollo spacecraft was about 25,000 km per hour, and it will take the spacecraft 52.8 minutes to pass through the Van Allen belt. So the scientists also measured that the average radiation doses that were received by the astronaut during that time with that speed of the spacecraft would be at most 11.4 rads, and if unshielded. So NASA had designed the spacecraft shield, adding more thickness and aluminium layer. So during that Apollo mission, turns out the average doses that received by the astronaut came out to be 0.38 rads. It's a huge difference, right? From 11.4 rads to 0.38 rads. But 0.38 rads of radiation still could kill the astronaut if they were dumb enough to spend several days in the middle of the belt. But why would they? So now let's understand more about radiation, where we can start to see the effect of radiation poisoning at 500 millisievert. If we convert 500 millisievert to rads, 500 millisievert is equal to 2.5 rads. Now let's take a look at average radiation doses received by the crew of the Apollo missions. And as you can see, the highest average radiation dose was on the Apollo 14 mission. The Apollo crew received about 1.14 rads on their flight through the Van Allen belt to the surface of the moon and back again via the same route. Yeah, 1.14 rad is lower than 2.5 rads, but how does 1.14 rads of radiation actually affect us? So, 1 rads or 10 millisieverts is the same as we exposed to the gamma rays and X-rays. To make it easier to understand, I will take CT scan as an example because CT scan use X-rays. 1 rads or 10 millisieverts is the same as dose of radiation as that of a CT scan of the abdomen and pelvis. So technically, the astronaut received 2 CT scans on their pelvis and abdomen on their way through the Van Allen belt. Is that gonna kill them? Obviously not. So despite of the challenge that caused concern for human spaceflight, we should be thanking Van Allen belt for protecting the life on Earth from utter annihilation and not to forget the beauty of the aurora. So that is all from me. Thank you for watching.